Under the series of unboxing technologies, today we are going to see blockchain as a beginner's perspective. Right at the outset, to understand what is blockchain is a distributed, decentralized public ledger. This is the book definition of, or the most simple form of definition of blockchain. So the key word that say the distributed kind of gives us an idea, which says that we are going to store some information not in one location but in multiple locations. So typically you can start to visualize, imagine a database, particularly a distributed database. Decentralized, that means it's not going to be in a single location, it's going to be in multiple locations. That could be multiple geographical location. Public ledger, that means many people will be able to access it or control it or handle it. There's many. May I request you to mute your mics, please? Thank you. So blockchain at the outset is a kind of a distributed database which is spread across multiple geographical locations and where multiple stakeholders will be able to access. Now, basically at Digitrati, we always believe in bridging business and technology. It would be always better to understand the technology from a business perspective. And for blockchain, we have today chosen banking as an example, as a business case scenario. So from that perspective, let's explore and understand blockchain. Blockchain is actually a technology that started in 2008 by a person with a pseudo name, Satoshi Nakamoto. We don't know the actual name of the person, who introduced the cryptocurrency. The cryptocurrency is where, it's the Bitcoin kind of a currency, which is a common denomination of a currency by using which you could trade between nations. The Bitcoin, if you browse, if you Google, you will know that is as a technology is basically a failure, but the technology that was used behind Bitcoin has become very, very popular, and that is what is the foundation for blockchain. This is the pseudo name person Satoshi Nakamoto introduced a concept of currency conversion without third party. So without third party is the key behind this blockchain transaction. So what do we mean by this third party? Now, if we are into trading, you want to trade with a US counterpart or an Australian counterpart. Ours is in Indian currency, which you have to convert and then trade with the Australian dollar or the US dollar, and we have a third party agency who will come into picture. To give a simple example, when I understand many of you here are students. From a beginner's perspective, we are exploring the technology. When you apply for a program in an engineering college or any seat, they ask you to get your documents attested by a third party. Your certificate that a government issued you, a board of exams issued a certificate, and that certificate, we now need to get it attested by a third party person. So that is the key here that you need to understand. Even in currency conversion, in transaction, we need a third party like that. Bitcoin introduced a concept where we don't need a third party. Now to take it forward, the technology that helped us execute this kind of transaction without a third party is called blockchain. There is a lot more to explore about blockchain. Let's first understand banking and the banking process, and from which we will understand blockchain. Banking, as you see in this timeline from 1762 to 2016, has evolved over a period of time, starting from the British banker, from that to moving between nations and spreading across a continent to taking it forward. It has traveled a very long path. So to give a simple example, until 1953, the bank accounts did not have a number. As you see here, the bank accounts were addressed only by using the name of the account holder, and there was no need for an account number. So from a person dependent transaction, we moved on into an account number. And from that account number, we have moved on into a digital transaction. So between 1920 and 1950, a lot of accounting machines came into picture, punch card machines came into picture, task automation started happening, and with IBM entering into the picture, mainframe computers coming into the picture, the banking process, the data processing centers and computer-based transaction all came into picture, and the digital banking industry started to evolve in this period of time. So this is how from account name to the digital account process. Now, what is bank dealing with? What are the purposes? Three important purposes of bank. They store the value. They help to transfer or move value from one person to another, and they give credit. These are the three transactions that a bank does. Now, slightly deviating from the banking story, I'm just moving on to Uber. Uber is something that all of us are familiar with. Uber, you can commute from one place to another. The interesting story behind Uber, Uber found it very, very difficult to launch Uber in the city of New York. In the city of New York, it took 6 months for Uber to get taxi drivers because almost 60 to 70% of the taxi drivers did not have a bank account. Okay, an interesting perspective. For being a taxi driver in Uber, you need to have a bank account. Again, the same story here. Alibaba.com. All of us are familiar. This is this festive season, and all of us know how discounts are flowing in various, e-commerce sites, Flipkart or Amazon or Alibaba. Now, what is the special story about Alibaba? In one of its, it has recorded 140 trillion transactions, and the transactions are happening from mobile devices, telephony, internet, either way of transaction, and 140 trillion transactions, bigger than any banking service provider. One e-commerce site is adding to a transaction that is bigger than any banking site. So from a personalized bank, we are moving on into a section where on a given day, we have 140 trillion transactions. That means the way when we started digitization of the banking accounts, whatever technology we use may not be able to help us, support us today in today's volume of business and volume of transactions that we are handling. Now, the most shocking information is that more than 2 billion of the world population do not have bank account. That means still 2 billion people need to have an account. That means you can visualize the volume of transaction we need to handle. Today, with the current strength of transaction itself, most of the time when we try to perform the transaction, we get an error message saying that the banking server is down or the network is down. We will not be able to continue the transaction. So what can we do? There is a delay in the transaction. May I request you to mute the mic? I see few of you have arrived and joined us now. Please mute your mics. Thank you so much. So with more users, we need to have a very different structure which can support this kind of a transaction. Now, what is the structure that we have now? We have a structure wherein we need to access the bank account 24/7, right? So there were days, 20 years ago, the banking transactions could be performed only between 9 a.m. and 1 p.m. And then slowly it got extended until 4 p.m. But today we perform banking transactions round the clock. and I need not go to the physical bank location or the branch. I can perform the transaction from any geographical location. The statement of account, I need not go to the bank to get a print. I can get it online. I can access it on my mobile device, on my PC. So this is the current technology. What we at the moment face is the current load, we are not able to handle with the existing technology. Number two, the transactions are across the geographical borders. That means the currency conversion and the third-party intermediate transactions are making it very, very complex. Simple things like these, I deposit a check in my bank account. I have to wait for my bank to process it. Then we have to wait for the check provider, that bank, to process it, and then the money to be remitted into the account. In normal transaction, it takes 2 working days for this kind of a transaction. We are in a fast food world, where we need the money immediately in our account. And how can we support such transactions? Now, if you look at the book definition of blockchain, what you see in my screen is the book definition of blockchain. So what are we trying to tell here? We are trying, it says that you can do something without the need of a third party. The way we started, the attestation of a document. Last year, the government of India announced that henceforth you need not go and get your document attested from anybody, because we are going to have this digital certificates. The moment you take your board exams or your university exam, these certificates are going to be stored in a digital repository. So you don't have to go and get attested by a third party person. So no third party. Opposed to writing entries in a single sheet, I am not going to keep the data in a single location, but I'm going to keep the data in multiple locations. Again, there is something, very, very key information behind this. That means that somebody has an access to my location where I keep the data. That means that, they will be able to access my entire data. So from the security perspective, I am going to keep my data in different geographical location, so that, nobody will be able to decipher my data or access my data. And we are going to have some chaining methods by which we can connect one piece of information with another. So this is the definition at the outset, which we need to understand in detail. So what is it? It is a distributed ledger, collection of blocks, and smart contracts. So my data is going to be distributed across location in the form of blocks by using an automated algorithm called smart contracts. To understand this, I'm just going with a simple example here to understand how a blockchain works. For over a period of 50-60 years, we have been working in and on to understand how do we move information from one location to another, safe and secure. So we have seen something like, various standards of moving data from one location to another, one platform to another platform. We have seen something like XML, which helps us to transfer the data. Now we have moved on into blockchain. Let's just visualize like, we are moving or shifting our house from one location to another. So what do? From the existing residential location, we will put them into cartons and boxes and then transport them into the new residential location, where we will unpack it and keep it in a location. So something similar to that is what we've been doing here when we do this file transfer and other things. We just pack them into bits and pieces and send from one location to another location. Again, in the received location, at the destination location, we put them all together, assemble them into a single lot and keep this information. So the sending piece of information in blockchain is going to remain the same, that I'm going to parcel it, break it into pieces and send from one location. The receiving end is what is going to differ, that it is going to be in multiple location. That means I am not going to simple thing like this. I am performing a banking transaction. So as most of you could visualize, it is a single rows data. The single rows data is not going into a single location. It is going to go into multiple locations and being stored. So even if somebody hacks one of my locations, say as I see here, here is the location A, somebody goes into that location and hacks the data, they will not be able to access my data as my data is split across and kept in multiple locations. All right. Now, how can I keep this data in multiple location? This data gets a digital certificate. The digital certificate is shared between location A, B, C, D. You know, if you have 10 locations, all the 10 locations are supported, connected by using this digital certificate. This digital certificate is not like a primary key or key value that we generate. It is auto-generated, and only the running algorithm behind the blockchain can validate them and connect them and help us to get the data, retrieve the data, not by human intervention. So the simple idea behind blockchain is that I have a data which I need to transfer and store it in a location, or I am performing a banking transaction. This needs to be stored. Say I am buying it on Amazon or Flipkart. When I press the button, all these information is going to go to the database, not to a single location, into multiple locations. And pieces of information are going to be stored in different locations. Blocks of information in different location. These blocks are chained by using digital certificates. These blocks will be committed. Now slowly we are understanding database terminologies here. They will all be committed together. That is what we looked at, this thing called the contract, smart contract. So when the split data goes into all the destined locations, say we have to put it in 5 different blocks, it goes to all the 5 different blocks. When it goes, 5 of these locations handshake with each other, and then automatically the data gets committed. When I have to retrieve the information again, 5 of them have to handshake with each other, and then the data will be retrieved. That is the simple way in which blockchain works. The same information that I told you, let's understand from the banking perspective. Here in picture 1, A wants to send money to B. So this transaction is represented by an online block. It is a block. Block basically can carry around 1 MB of data. That is the size restriction. You know, it's like, you know, a row can hold this much of data. So similar to that, this block can hold 1 MB of data. So this block is going to be stored in multiple locations. This data can be split into multiple blocks and goes into the network and goes into the different location. As you see in picture 4, when it has reached all the destination location, the distributed destination location, each of them handshake with each other to verify the digital signature. When it is done, the transaction is stored as an indelible, transparent record of transaction. That means unchanged, you know, you cannot edit it. It is going to be unmutable. The transaction becomes permanent. It is a very, very secure, permanent transaction and a transparent transaction, and immediately the money will move from A to B's account. And here, the best part is there is no human intervention. There is no third-party validation. The whole thing happens between the sender and the receiver. Okay, so how is this going to happen? This is basic. Another very important thing behind this is the smart contract. The smart contract needs to be understood very well because this is automatic, it is fast, it is direct, it's cheap, and it is transparent. How is it transparent? As we see here, picture 4, when it reaches each of the distributed location, the digital signature is verified and they handshake, and then the data is committed. It is direct and there is no third party involved in it. Okay, so the disintermediation, transparency, and provenance is the key for blockchain, the most significant factors. So there is no third party involved. And when the transaction takes place, all the parties involved in the transaction can see the information, and it is an unmutable information. So it is an universal truth. It is a single source of information. There are no different versions of the truth. You know, today in a banking transaction, the same example I started with, I deposit a check, my banker says I have processed, but the sender bank says that we haven't received it, you have to wait for a day or two. So, you know, there is a delay, there is a latency. Here it is transparent, and you know, and you can see as that transaction is happening, what is happening, where is it, and when will it reach you, you can see it. And provenance is very, very important, that the digital asset is farmed and where did it originate, where is it at the moment, and where is it getting accumulated or stored or being placed is very, very clearly maintained. So you know that these immutable transactions which cannot be altered are moving from the source A to the destination B in this format can be very clearly handled and maintained. So this is yet another very, very important thing. So we've been seeing three important things here. So when we started, we have talked about this distributed database and ledger being available in multiple location and immutable transaction. Again, now the next three important things that we see here are disintermediation, transparency, and provenance. I may be repeating the same fact again and again. Now to understand, why are banks interested? See, we've been seeing that they have been working from 1760s until today. How is blockchain going to be useful for them? A, money transfer. So there is not going to be any latency, no delay when you transfer money by using this blockchain technology. Record keeping becomes very, very simple. One, because your record is going to be stored in multiple locations. There is a safety and security of the data that is involved in it. That gives banking an edge over anything else, that they will be able to split the data and keep the data in multiple locations. Number two, all banks can depend on a single repository. Each of the bank need not have a separate repository. There is a common repository of data from which we will be able to maintain and perform the transaction. And the backend operations. Backend operations are going to become very, very simple. Of course, large. Of course, it's going to be huge, but it's going to be very, very simple, maintained from one location. So that is why this is going to give a cutting edge to bank, and banks are interested in blockchain. The key behind the bank's interest is that single source of information. All the customers' data across banks are going to be stored in a single location from which the transactions are going to be performed. How is this going to be a single location? We would talk about it in a few minutes about the various networks that are supported by banks. We will talk about that in the next few minutes. Now, to understand what is blockchain, it basically replicates the data from one location to multiple locations and keeps the information. The paper-intensive international trade processes will be made simple because there are no third-party intervention at all. In one go, we will be able to complete the transaction. The entire electronic transaction is going to be a decentralized ledger. So it's not a load on a single third-party control who is going to perform the activity, or it's not going to be the sender's bank who is going to keep a copy of the data, or the receiver. It is a decentralized ledger where the entire data is going to be available. All the party participating in this activity will have an access to the data and single source of information. The very, very important value behind the blockchain activity. Blockchain also enables us to track the documentation because it's transparent. So we know who has originated the transaction, from which location to which location, at what time, and at real time, you will be able to see this information. Authenticate ownership of assets digitally. The digital assets, ownership of digital assets is the key behind this. A simple thing we can see here is this, as the example that I mentioned when we started, you need to get your certificates attested by a third party, a notary or a gazetted officer. Here, maintaining the digital assets becomes very, very simple. Supposing, you have a property and you want to register that property. It's not that very simple. You need to get it attested, you need to have a witness, you need to have somebody validating that it is your property. Even though you are the owner, you pay the taxes, but still these kind of things come into the picture. Here, when the property is a digital asset, when it is all a digital asset, the ownership of digital assets and authenticating them is very, very easily and beautifully handled under the blockchain technology. Unalterable ledger in real time. So when I mentioned about this tracking the documentation, we mentioned that everything is in real time. There is no latency, and unalterable or unmutable transaction. Once a transaction is performed, you cannot delete the transaction. You cannot remove the transaction. The transaction will remain there forever. So the key here is blockchain is still new, but there is a huge potential, huge impact on business and all businesses. The way, an example, the other sectors would be healthcare and supply chain management, which would be benefited by this blockchain. Healthcare, to give an outline about this today. I hope you are all able to follow me. Is anyone experiencing any difficulty? Can anyone reply? No. Thank you. I get that. So if you take healthcare as an example, healthcare today, we travel from one location to another and we want our records to be available, the health records to be available wherever we travel to. We will check into it. Somebody has given a note that you are not able to connect. Our technical team is checking into your connectivity. In the healthcare sector, the records can be stored in multiple locations as a distributed ledger, and wherever you travel, you will be able to access your healthcare records. And when there is a need, you will be able to use it. And there is going to be a common repository across which various healthcare service providers will be able to access the information. Same is in the case of supply chain management. Now, the most important and critical question comes here is it safe to use blockchain? Put my data in a common repository, in a centralized repository? Of course, yes, it is safe. Why? When two parties execute a transaction, there is no intermediary, there is no third party involved in it. Number two, there is no human intervention. That itself means that it's going to be safe. Number three, the data is going as blocks and chained blocks, and the blocks have a digital signature. Only when the digital signature match, they will be able to talk to each other. Number four is that there is cryptography applied on it. So that means, you will not be able to decipher the data unless and otherwise you get to know what is the ciphering technology, the crypto algorithm that is being used, what is the encryption technique that is being used. Even then, even if you know the encryption keys and you are able to decipher the data is not available in single location. I may get to know one server location where the data goes, but my data is available in multiple locations, decentralized, distributed databases. So I will not be able to access that information. So my data is secure. I summarize, no intermediary, no human intervention, records are maintained in blocks, and cryptography makes that the data is secure and safe. The critical factor that makes blockchain work is the global network. So we have four important things that we need to understand here: the rights, the obligations, the controls, and the standards, right? So who owns what? Who will take the ownership? What are the obligations? Who can send? Who can receive? How is it controlled? Who will communicate? Who will take care of it? What is the standard? Which encryption standard are we going to use? So these things, we need to define them. We are still evolving. We haven't come to a stage where we could say it is perfectly defined and this is how we are going to work on it. We are still working on it, because the key here is the global network. Again, here the public network, the private network, and various other factors will also fall into picture. Another very, very significant factor that we need to take into consideration for blockchain is considering the fact of the existing number of transaction and also the future transaction we would have to cater to, and planning the network to support to it. So it's not going to be the same strength of the transactions that we are going to perform. The moment we digitize and we are on blockchain, our number of transactions would double and triple in no time. So we need to know how our network will be capable of supporting this network. Now that is a physical network. Now talking about the blockchain network. Blockchain has four different types of networks called the consortium blockchain. Consortium blockchain is like what we talked about, the banking sector or the healthcare sector. So various banking service providers join hands together to create a consortium, putting all their customers' data in the consortium. So each of the banking sector who is a part of it, who is a member of it, will be able to access the data. It is open, it is transparent, so I will not be able to hide how many customers I have, and banker B will not be able to hide from me that how many customers banker B has. So it's going to be open, transparent, and it's a consortium where all the data of the participating parties is going to be available. Semi-private blockchains. So I have few clients and I want to keep all my clients' data in a blockchain and in a group, and all my clients and we would be able to interact with each other. That's a semi-private blockchain. A private blockchain is where, for a specific customer who believes that their data should be secure, decentralized, faster transaction, transparent, we can have a private blockchain and the public blockchain. So this public blockchain alone, I'm going to take a minute to explain it. Let's understand Wikipedia today. In Wikipedia, each one of us can contribute. Supposing there is some information that is available in Wikipedia, and I think I have a very, very special information about that and I want to add it. All I need to do is I have to go into my login and post the data. When I post the data today in Wikipedia, what happens is it says that it would verify and approve my data in a bit of time, right? So there is a latency. Now my data gets verified and then it is getting posted. Now there is another person or one of you who is saying that the information that I have added is wrong, and you are giving some proof and you're saying that is what is the right. Now again, there is someone who is going to verify that and upload it. Now let's assume we are on blockchain. Whole of Wikipedia is on blockchain. The moment I put my data, immediately it will be verified and transparent. You can see and I can see that Jayanti has edited this information and added this piece of information. Okay, it is permanent. It is unmutable transaction. It will be there. Now say I see a name, Suganya. Suganya says that my information is wrong, and Ms. Suganya gives some other information. She adds some facts here. Then it will also say that this fact is contested by Ms. Suganya and the data is available. So the whole of Wikipedia, which is already an open website, public information, can be available in public blockchain, distributed, decentralized source of data where the communication is transparent and the transaction takes place without any latency, that is in real time. The four different blockchain network. So what's happening in blockchain today? Large investments are happening in blockchain. Many fundings and many new projects are running. And there are, you might have heard of so many hackathons and labs and collaborations and open source platforms that are taking.
Hello.
And a lot of investments are happening in the blockchain arena, and people want to explore and see how blockchain can fit into various different business domain. Yes, a real-time, open source, trusted platform, which will help us to transmit data securely, will reduce the cost of processing payment, and where we could create new products and services, generate important new revenue stream. And it's the initial cost of creating the infrastructure is going to be a challenge, but once the infrastructure is available, we will be able to perform transaction easily, like in real time. Okay, it's the key, very, very nice information. The technology will only work if everyone adopts it. So it has to be all or nothing. Only when all the banking service providers put their hands together to join the banking consortium and put the data, we will be able to enjoy the benefit of blockchain. Similarly, for healthcare, when all the healthcare service providers put their data, we will know that. And yet another significant fact is that it will bring down the cost and also reduce inefficiencies. Of course, the latency will not be there. That means it will be real time. That means it will be very, very efficient. That means we will have, at the same time as you do a transaction, the transaction would be committed. Right? So the digital assets, we started talking about the digital certificate. The digital assets is a platform for truth and trust. It is immutable, unhackable, distributed ledger, transparency. So the transparent distributed database, which is immutable and unhackable, is blockchain. Again, to summarize, the 14 ways blockchain will transform banking. Interbank transaction. Today, even though there are these IMPS transactions, we always see there is a delay, there is a latency from the time we perform the transaction to the time the realization happens. Remittance. I can remit this minute to any geographical location. Smart contract, which we talked at the beginning. Crypto banking. Record sharing and storing. Each bank need not maintain their separate record storing database servers and things. It's going to be in the common repository. Clearing and settlement of transaction. Loan syndication. I will not be able to bluff that I haven't taken any loan, because when I apply for a loan and it is in the banking consortium blockchain, it will know that all my previous history of transaction. Regulatory technology. So everybody will fall under this, and the regulation will help us to put things in place. I wouldn't have to go and fill up this know your customer KYC form very often. That is one thing that many of us do not like. Every time we go to a bank or any service provider, they ask us to fill a KYC form. Now it's all going to be a single repository where our KYC is validated. We don't have to do that again and again. Reporting, trade, data security, increasing the transparency, serving the unbanked. So the fact that we started with that there are 2 billion people yet to have this bank account, and we can see that we will be able to achieve it by implementing blockchain. And what is blockchain? It is not about incremental change. It is the inflection point. See, it's not that we have this, that is why it is wrong to understand that blockchain is a distributed database alone. Distributed database, it is something that has been available for a long time. We've been talking about network databases, distributed databases, hierarchical databases. It's simply not distributed database. Distributed database is also a part of it. with the decentralized ledger and with transparency in place. Now that most of you are interested in knowing what will make me be a part of this blockchain. I'm a technology student of technology. I'm learning information technology. I'm already working in information technology. What will make me work for blockchain? So what are the blockchain development tools? Actually, it is a bit shocking. Supposing, you just go and browse popular programming languages in blockchain, you see so many technology that are a part of it. Then there are something called development tools for blockchain. It is yet another big list. And then there is something called dApps. Okay, so tools for dApps is also distributed apps, that is also there. And then these are quite confusing. Now what we will do is, let's have a look at the career path available, or that is in blockchain, the career path in blockchain, which will help us understand the technology behind it. You can plan a career based on a programming languages. So if you are good at programming language, there is a career path in the development activities. So the development activities itself could be put into three important segments, like a programming language specialist, somebody who can work on version control and management too, and the web development skills, the scripts and other things, the programming skills. The database knowledge will also help you find an employment in blockchain. Then the blockchain's fundamentals and computing, distributed computing platform, that is yet another part that is very important. The containers in which we would be hosting this blockchain, security, and the cloud finally where we would be deploy the server. Okay, the various career path. Now I have an interesting information here to go ahead. Before that, I summarize. Blockchain is a secure distributed database where records are stored indelibly. So unmutable, unchangeable set of records stored in a distributed database. And the most important use of blockchain is the ownership of digital assets by all the parties that are involved in the transaction. So to summarize, the technology skills for blockchain are programming skills, database skills, security skills, and cloud computing skills. So the cloud computing will take care of all the servers, administration, backup, restoration activity. Security will take care of the cryptography, securing, making your network secured and all that. Database will take care of the distributed databases, their communication and all that. Programming skills will take care of receiving the information from the end user and distributing into this distributed location. Right? At the moment, we are talking about blockchain, and the next big change is going to be blockchain, which is going to help to accumulate data. By using that accumulated data, we can go a big way in artificial intelligence.